Hello guys, my name is teacher Thant, and today I'm going to discuss about Unit 3, Chapter 11, which is the chapter of Electromagnetic Spectrum. So the topics that we are going to cover today is that we should know that electromagnetic spectrum, it consists of radio waves, microwaves, infrared rays, visible light, UV rays, X-rays, and gamma rays. These are the type of rays, the different type of waves that are in the electromagnetic spectrum. You should be concerned in IGCSE Physics. And about those waves, you should know their order, which are described as their decreasing wavelength or frequency, okay? And then you also need to know the colors of the electromagnetic spectrum. And finally, you need to be able to explain some of the uses, some of the harmful effects, and how you can protect yourselves from harmful electromagnetic waves. Now, when we talk about electromagnetic spectrum, we need to first talk about electromagnetic radiation. So electromagnetic radiation, it is simply a radiation which has both electric and magnetic field. So electromagnetic spectrum, it is the entire distribution of all of these electromagnetic radiation, and these radiation are different based on their frequency or wavelength. Now, if you look at the complete magnetic spectrum, you will see that it is divided into radio waves, microwaves, infrared waves, and visible light, which is the color, which is the reason that we can see now. It is solely due to the visible light. And we've got UV rays, X-rays, and gamma rays. So apart from the visible light, which is composed of 7 colors, we cannot see any other rays at all with our normal eyes. Now, the 7 colors are red, orange, yellow, green, blue, indigo, and violet. You do not need to remember the exact number, the wavelength number. However, you need to remember the order of your electromagnetic spectrum, okay? And you also need to know which colors come first, which color comes last, which color has the longest wavelength, and which color has the shortest wavelength. Now, all electromagnetic spectrum or waves have 4 similar properties, which is they transfer energy or information, they are all transverse waves, they travel at the speed of light, which is 3 into 10 to the power 8 meter per second in vacuum or air. And finally, as all waves properties are, they can be reflected, refracted, and diffracted. So these 4 properties are the common similarities of all electromagnetic waves. Now, the types of electromagnetic radiation. Now, if you look at this diagram, you do not need to know anything other than comparing the wavelengths, okay? In the exam, you're expected to compare the wavelength of, let's say, X-rays and microwaves, or visible light and radio waves, okay? You need to be able to tell your examiners which waves have shorter wavelength, longer wavelength, which waves have higher frequency or shorter frequency, okay? Now, if we look at this here, radio wave, on the leftmost hand side of it, it has the longest wavelength, if you notice here, but it has also the lowest frequency. It is because of the equation V is equals to F lambda. You need to go back to my previous video if you don't know the relationship between these two. And gamma rays have the shortest wavelength. However, they do have the highest frequency, which is why they are very harmful to us. Now, as we go from left to right, we will notice that your wavelengths become shorter and shorter and shorter, but your frequency, it becomes higher and higher and higher. Okay, so that's the only two relationship that you need to take care of in electromagnetic radiation. So a good way to remember the order of your waves is by following this code below, okay, which is Graham's xylophone uses very interesting musical rhythms. So if we take the underlined words from it, we can try to write all the rays in their order. Okay, it starts from gamma rays, G, X-rays, xylophone, uses U comes from ultraviolet, V for visible light, I for infrared, M for microwaves, and R for radio waves. Now, radio waves have the longest wavelength and the lowest frequency, as we see in the slide before. So radio waves are used mainly for communication. So if we see here, this is a radio tower and we have a transmitter on top of it, which is going to transmit the radio waves, and we are going to receive these radio waves by the aerial or the antenna on our radio, and the radio will change the radio waves that we receive into sound waves so that we can hear it. But let's look at why is a radio suitable for communication. It is simply because all radio waves can go through walls and surfaces over very long distances. They can also travel at the speed of light, 3 into 10 to the power meter 8 10 power 8 meter per second, so they are very fast information, and they are not harmful because they have very low frequency. Now let's take a look at microwaves. Microwaves are used for communications, radar, and cooking foods. Now at your home, you are most probably likely to have a microwave. Now you've got microwave and an oven. So a microwave is better for cooking your food because the water molecules within your food will be able to absorb all the microwaves to become hot. Okay, so the food cooks inside as well thoroughly. Now normal ovens without a microwave property can only cook the outside of your food. But one precaution to take here is to use a metal casing. Now, microwaves are also used in mobile phones for communication, but we will notice here that they transmit much less energy so that our brains are not cooked at all. Now on the right side, we can see a radar application of microwaves. Now what it says here is if we have a radar here, it is going to send out the microwaves, and then the microwaves are going to get sent back here. Okay, so what we should take note of is the total time taken to travel once and back. Okay, so if we took 5 minutes to travel to the plane, if the waves take 5 minutes to travel to the plane, it takes a total of 10 minutes. And we can calculate the distance by using this formula: distance equals to speed into time. Alright, speed is simply what? 3 into 10 to the power 8 meter per second, because all waves travel in air or in vacuum at that speed. So if we multiply 10 minutes with speed, we will get the total distance. But the distance between the airplane and the microwave dish should be halved because the time that we used was back and forth. That's why distance should be halved, because the waves travel once to the plane and back to the receiver. Now infrared waves. Now all objects, including our bodies, emit heat. That's why you feel slightly warm all the time, and that is called infrared radiation. If an object is hotter, it will produce more infrared radiation because the heat energy is transferred by that infrared radiation. Now, if we take a look at this, you will notice that infrared radiation, the high zones are most likely to be represented by bright light, okay, and the dark areas or the colors which are not as bright will be cold areas. So right now the back of this woman is going to be a very hot area. The eyes and the mouth of this tiny chihuahua is going to be very high, very hot as well. Now, infrared radiation, if you are overly exposed to it, it will cause skin burns, and the precaution that you can take is simply to avoid being exposed to it. So avoid overexposure. Now, infrared waves can be used in many different sorts of ways. I'm going to give you a few examples on where it can be used. First of all, it can be used on infrared cameras. You may have seen them in Navy SEALs movies. Okay, so we can create images when there is no visible light. Okay, we do not even need light to create images. They are used because it's only detecting the heat source. So we can use it to search for people in lost buildings, and when criminals are on the run in the forest, as if you've seen in movies, we can use infrared cameras. Now, the remote control that you have in your living room is also an application of infrared rays. Why can we use that? Because the waves are not harmful at all, and they have very low penetrating power, and they can operate over only small distances. Now, if you go to a marketplace or a city mart, you can see a barcode scanner as well. It is also an application of infrared radiation. So the visible light from the laser, it can be used to read compact discs or barcodes. Okay, so it is a way of storing and reading information as well. And finally, you will in this COVID age, you will have seen this thermometer somewhere. It is also an application of infrared radiation. Okay, so we can measure people's heat just by without any contact at all due to the infrared radiation. Okay, so infrared cameras, remote controls, barcode scanner, and infrared thermometers. Now take note that you should recognize some of the uses of these applications, because in exams they will ask you how are infrared waves used, how are infrared radiations used. It is a question that they commonly ask, similar for all other waves as well. Now, ultraviolet light or UV rays, as you have seen in skincare commercials, right? So part of the sunlight is called UV, okay, ultraviolet light, and overexposure to ultraviolet rays can cause harm to human bodies. Now let's take a look at this. First of all, it can cause eye cancer, and a way to prevent eye cancer from UV rays is simply to wear sunglasses or UV protected glasses. All right, protect your eyes from direct sunlight. And secondly, it can cause sunburn or skin cancer, and a good way for you to protect your skin from UV rays is simply to wear a sunscreen, use an umbrella, stay under the shade. Now, UV rays are not all that bad. There are actually some good uses of UV rays. Where we can use them is security marker pans or fluorescence tube. Okay, they can light up in the dark, and then the UV light, it can kill mosquitoes and bugs. Alright, so this is an application that you might have seen in restaurants near you. Okay. So I want to talk about ozone depletion in relation to the sunburn or skin cancer. Now, ozone, as you have learned in chemistry, it is in the atmosphere, and it is the layer around the earth which protects humans by absorbing all the UV light in sunlight. But in recent years, the pollution has been occurring, and as a result, the ozone layer is decreasing, meaning that more and more of the UV rays are reaching the Earth's surface, and it's causing more skin cancer problems for humans. Alright, X-rays. You've heard of this before as well. X-rays can pass through soft body tissue, but it can pass through our bones. That's why we're able to see those white solid images on X-ray photographs. Now, X-ray pictures can be taken to check whether bones are broken or not by leaving shadows on photographs. Okay, so the images are inverted, so your shadows look white, but they indeed are shadows. So shadows is a key word. Okay, so what happened was when X-rays were passing through, the bones absorbed the X-ray waves. Secondly, the radiographers are people who take X-rays for you when you go to the hospital. Now, they have to protect themselves behind a LED screen or wear protectable clothing because these X-rays are very radioactive and they can cause cancer. Now, you might think, how about me? Why don't I have to wear any protective clothing when I go to the X-ray center? Okay, it's because you are exposed to it only for a short amount of time, but these radiographers are exposed to X-rays for long periods of time throughout their occupation. And finally, X-rays can also be used to check internal structures of various objects, such as suitcases in airports or even cracks in buildings. Now, gamma rays. Okay, so gamma rays are the last ray that we're going to learn today. They are highly penetrating rays which can cause damage to living cells. So gamma rays can cause or cure cancer. Now, if we are exposed to it in the wrong way, the damage will cause mutations in the negative manner, which can lead us to cancer. But there are actually some good uses of gamma rays as well, which is practiced in the medical industry widely. First of all, gamma rays are used to sterilize medical instruments because they can kill all sorts of bacteria, okay, on your equipment or your instrument. Now, the second thing is food. Okay, so gamma ray can kill microorganisms in food, such as tiny bacteria and all that. So it will delay the decay of your food, as you can see in the picture. All right, and then last application of gamma ray in medical industry is treating cancer by using radiotherapy. Okay, so if a tumor is found on a certain part of your head or your brain, gamma rays will be targeted towards it by using complex medical equipments. But the main thing to take note of here is that large doses of gamma rays, they are targeted directly towards where your tumor is growing, and then it will kill the growth and the cancer cells completely. Alright, so that's about it, and I'm going to summarize what I discussed today. So in exams, you're most probably likely to see the question state properties that are the same for all parts of the electromagnetic spectrum, or they can ask you state similarities between, let's say, X-rays and radio waves. Okay, so since X-rays and radio waves are both electromagnetic waves, you just write down some similar properties for it, which is that they are all transverse wave, they travel at the speed of light, they can travel in vacuum through walls or surfaces, they can transfer energy or information, and as all waves are, they can be reflected, refracted, and diffracted. Now, let's take a look at some other common questions. So in exams about waves, they will ask you all the time to compare the length and frequency of wavelengths, which one is longer, which one is shorter. Now, a sample question would be that there are 7 colors which we can see in the visible light spectrum, but which color has the longest wavelength? So in order to answer these questions, you need to know this diagram by heart. Okay, which waves come first, which waves come later, which waves have shorter wavelength, which waves have higher frequency, and all that. You need to know all about those. So only when you remember this, you will be able to answer that red has the longest wavelength. Now, the second type of question that they might be asking you is to describe the uses or the damage that can be caused by, or how to protect yourself against a certain type of waves of the electromagnetic spectrum. Okay, so go back and revise on what we just discussed to be able to answer all these questions thoroughly. Okay, they are not going to ask you to write an essay, but you should be able to write down point forms. And finally, they will ask you to describe the differences between X and Y. X and Y are two of the electromagnetic spectrum waves. Okay, they can ask you to describe the differences all the time. So in order to answer this question, you can always go and refer to wavelength and frequency, because of course when two waves are different, it is because of wavelength and frequency. Now, a sample question is state one similarity and one difference between X-rays and radio waves. So as for similarity, you can say any common electromagnetic properties, such as they can travel through vacuum or they travel at the speed of light. Okay, and as for the differences, you can say that radio waves have longer wavelength or smaller frequency. Okay, you can always refer to wavelength and frequency in order to answer your differences. Alright, so that is all for my today's lesson. I hope that you find it useful, and I'll see you again next time.